Today's class we'll discuss about the chapter 3, Global Navigation Satellite Systems. This is Geomatics third module and chapter. So in this Global Navigation Satellite Systems, they are referred as GNSS, represent a constellation of satellites providing signals from space, transmitting positions and time data. GNSS provide global coverage, and GNSS receivers determine the location by using timing and positioning data code in the signals from space. So the GNSS is a constellation of satellites that provided in order to locate the objects that are around the world. So each global navigation satellite systems are assigned to the different countries. For example, Natstar, GPS of USA, and GLONASS of Russia are the example of GNSS. The types of GNSS are: first of all, Natstar GPS. Natstar GPS abbreviation is Navigation Satellites, Timing, Arranging, Global Positioning Systems. So it have the following properties. GPS is the all-weather space-based navigation system developed by the U.S. Department of Defense to meet the military needs to determine their positions, velocity, and time, and common reference systems anywhere on or near the Earth. It is a high accurately based navigation GNSS, Global Navigation Satellite Systems. It's a constellation of satellites. So we are using the GPS with the help of the Natstar. It was initially used for military purpose, but later promoted for the civilian use. The systems originated in 1973, and the first satellite was launched in 1978. It having the following specifications. That means how much satellite is covered and how much amount of altitude it having, and the inclination are mentioned in the following points. The dominant GPS constellation should have a minimum of 24 satellites of full coverage. The satellites are distributed in 6 orbiting planes at an altitude of 20,200 kilometers. The orbital planes have an inclination of 55 degrees with the equators. These are the specifications which each satellite of Natstar is rotating around the Earth. Now the system has 31 satellites in 6 orbital planes. So it is improved its accuracy by providing more number of satellites around the Earth. Second one is GLONASS. GLONASS is Global Navigation Sputnikovaya Sigma. This is a Russian satellites, global navigation satellite systems. This is a satellite-based navigation system by the Russian Aerospace Defense Force. GLONASS began in 1976 and having 26 satellites in 3 orbital planes. It is 24 active and 2 reserves, and at an altitude of 19,100 kilometers and an inclination of 64.8 degree equator. Uses the PZ90 datum, and the GLONASS operating system is more efficient at the northern altitude. So it is the GLONASS and the Natstar are the mainly fully operational global navigation satellite systems. The third one is Galileo. It is the European navigation satellite systems. It is developed by the European Union. The European Space Agency initiated Galileo. The system will provide high accurate guaranteed position services under civilian controls. But the system is not fully operational yet. However, the full system having the 30 satellites and 27 operational and 3 space by 2019 is already working, and the positioned 3 circle mediums of Earth orbits at an altitude of 23,616 km height at an inclination of 56 degrees. They're having the pretty good coverage around the around the European continent. And the fourth one is Budo. Budo is the Chinese navigation satellite systems. It consists of two separable satellite systems. Budo 1 offers limited coverage and applications. It consists of 3 satellites and famous for uses of China and neighboring countries. Budo 2 is a compass. It proves operational with the 10 satellites in 2011. It has 35 satellites in 2020. These are the different types of satellites used by the different countries. So, having the different specifications, the GLONASS and the Navstar are the global navigation systems. The rest of them are the regional satellite systems that used for locating objects around that particular country. Next one, fifth one is IRNSS, that is Indian Regional Navigation Satellite Systems. It is the regional navigation systems, not a global navigation systems. NAVIC, the navigation in Indian constellations, it is anonymous regional navigation systems that provides accurate real-time positioning developed by the ISRO. It covers India and regions extends 1,500 kilometers around it. It plans for future extensions. It having two levels of services, that is standard positioning service for civilian use and the restricted use for the other operational uses, that for the military uses. Next one is QZS, that is Quasi Zenith, that is Japan Navigation Satellite Systems. It proposed for the 3 satellites regional systems that would receive within Japan. So it is for communication services and also it used in the mobile applications. So these are the types of global navigation satellite systems. The different properties of GPS we are going to discuss on the later sections. So it is combined in a tabular column with the different properties like the number of satellites, altitude, global or it is regional, and the operational status. Next thing is we are going to discuss about the global positioning systems, that is GPS. Global positioning system is a radio navigation system provided by the US Department of Defense. That is, we already discussed that the Navstar having the fully operational GPS systems under the US Department of Defense and is now used for the civilian use also. So it is going to discussed in detail in these sessions. It having already discussed that 24 satellite constellations and a GPS receiver, that is user on the earth will receive the radio signals from the satellites, and the signals it is possible to calculate the position on the earth. By using this GPS we are going to find out the exact latitude and longitude of the object, that is the GPS receiver, the user's GPS, user segments. The classification we are going to discuss on the later sessions. And now we are going to discuss about the other advantages of GPS. It having the relatively high positioning accuracy. So it having a different level of accuracy depending about the amount of sensors we are using on the devices. So having meter level of accuracy, centimeter level of accuracy, different level of accuracies are there. Capable of determining the velocity and time. The objects, if you are moving in a car, we can locate the velocity and how much, what the time at the particular traveling time. Third one is signal availability anywhere on the globe. Anywhere on the globe we can provide the exact latitude and longitude. No user charges, all weather systems. It is operational of the 24-hour window, and the positioning information is in 3 dimensions, that is horizontal latitude and longitude, vertical is the elevations. So these are the points, these are the advantages of GPS. So if in all of the systems we can locate anywhere in the globe, the latitude and longitude is on the horizontal side, and if we need the elevations, we can also locate it by using the GPS. The components of GPS are coming under sections like GPS comprises of 3 segments, it is space segment, control segment, and user segments. These are the main types of GPS, components of GPS. The first one is space segment. Space segments, we already know that it consists of GPS satellite constellations, which allows determine the positions. So the combined effect of these 3 segments in the GPS, we are going to locate the position of a object. So in the space segments, 24 satellites is located in the 6 orbits in altitude 20,200 kilometers, with each plane inclined at the 55-degree orbit. They are powered by solar panels and batteries provided as a secondary power. So normally the satellite systems having the atomic clocks, it is very pretty accurate. Each second that matters for locating the positioning of the object. The space segment is also designed that there will be a minimum of 4 satellites visible at any point on the surface of at any time. So a minimum of 4 satellites is required to the, if you have to locate a object at a pretty good accuracy, you need the 4 satellites, constellation of 4 satellites. A very accurate atomic clock having a frequency of 10.23 megahertz in GPS satellites provided the most accurate timing systems. So in seconds, we are in microseconds, milliseconds, the accuracy or the distance of the object will change. So you have to accurately locate if we want to accurately locate the object, we need a pretty accurate clock. Now, the basic functions of satellites are to receive and storage data transmitted by the control segments, maintains accuracy time by the atomic clocks, transmit information and signals to users, provide a platform for the orbit for transmitters. So it is also the space segment is also considered as the platform. We already studied the different types of platforms. So it is also act as a platform for the sensors to receive and emit the signals. The next segment is the control segments. Is located on the Earth. The control segments having again the classification: 1 master station and 5 monitoring stations and 4 ground antenna stations. The control segments track the GPS satellites, update their orbiting positions, and calibrate and synchronize their clocks. So the control segment having, this is the master control segment, having the pretty much control of the entire actions that are going to happen in a GPS tracking. Another important functions of the control segment is to determine the orbit of each satellite and predict its path for the next 24 hours. So the satellite should be orbited in a way that the control segments are intended to do in the next 24-hour window. So it is controlled by the control segments. It's pretty clear in that sentence. There may be a possibility of satellites traveling slightly out of orbit, so ground monitors have to keep in track of the satellite orbits, altitude, location, and the speeds. So they control the entire speed, the entire orbit, and the entire inclination throughout the rotation for the next 24 hours. So the entire data, like the satellite orbits, altitude, location, speed, is called epimerisis. The data is called epimerisis. It is only valid for 6 hours and transmitted by the codes to the GPS receivers of that is inside the GPS satellites. The location of master stations, it is mainly near the Colorado Springs, USA. The monitoring stations track the navigation signals of all satellites. The information is then processed at the master control stations. The master control stations is used to update the satellite navigation messages. The master station sends the updated navigation information to the satellites through the ground antennas. The master station computes the clock corrections derived from 1 week track informations. It is collected from the 5 monitoring stations around the world. It is also ensures the satellites repositioning it is necessary. So there is 5 monitoring stations are there. So they monitor the entire tracking of the satellites and is sent to the master stations. They will again check and transmit it to the 4 ground antennas. So the 3 types of levels of operations are doing in the control segments. The last but the least, the user segments. The user segments are the devices that having in the hands of users, just like the mobiles, etc. The user segment consists of GPS receivers used to receive the signals for determining the positioning and time. Typically, the applications with the GPS receiver are land navigation, marine navigation, aerial navigation, surveys. The GPS has a variety of applications of land, sea, and air. Simply, if we have to locate our location of the mobile, we are going to turn on the GPS and you are going to know where we are standing. Simply, these GPS properties are used for the GPS surveying and different navigation processes like land navigation, marine navigation, aerial navigations, etc. So this is only for the today's class. We have discussed in the sessions the different types of global navigation satellite systems. With the next one, the global positioning systems, GPS and its components. Thank you.